All right, it's the Ask Them Anything panel. So ask whatever you want. We have 3 mic runners. Wow, look at this. Amazing. Mic runners are going to be busy. So let's start right off the bat. You know who they are. You've been watching them for the past 2 days. So let's start with our first question, number 3.
Question with regard to shared pointer and the atomic increment decrement. If in the language that, like for instance, a double precision number, there's no guarantee that it will be done in an atomic operation when passed, say, to a function. Why was the decision made to do an atomic increment decrement as opposed to allowing a coarser grain locking and then not incurring the overhead?
That's to support the usual thread safety guarantee. So if you've got, say, 2 ints on completely different threads that are different objects, then the threads can modify them simultaneously. Imagine that you've got 2 threads with different shared putter objects, so SP1 and SP2, and they're both copying from them or assigning to them. So read writes on different threads. But these shared putters happen to be owning the same underlying object with the same ref count. Well, copying them or assigning to them is going to increment or decrement that shared ref count. So even though the user didn't have multiple threads simultaneously partying on a single object in memory, behind the scenes they're modifying the shared variable. And so to preserve the usual thread safety guarantees provided automatically by vector and list, the STL needs to protect it with atomic operations, interlocked increment, or other platform intrinsics.
Thank you.
So if you want to apply that to something like a double, then you just say atomic double.
Is GoNAS stepping in for you?
Yeah.
Oh, okay, I didn't know that. All right.
Yeah.
Okay.
All right, 2.
No, it's fine. It's fine.
Hi, everyone. So I think we all agree that native code is great, but I just want to ask, when you're not writing native code, what languages do you guys use to get things done?
How did you get into when we're not writing native code?
This one go in order?
Z shell.
Yeah, that's right.
I don't remember the last time I actually wrote non-native code. I've modified a lot of Python code, but I don't think I actually wrote any of it. I just copied other people's. I don't understand this.
I have written Java code off and on.
And I believe you also were involved in a JVM implementation, which was written in?
Which was, at the time, that was mostly written in C, some C++.
Shell script, awk, that kind of stuff.
I have the luxury of being just a C++ developer, but occasionally I write Windows batch files. I win the award for most evil.
I don't know, Python maybe. A lot of LaTeX lately. I wrote 40 lines of C# 2 weeks ago. 40.
All right, number 1.
So my question is about adoption. In my limited personal experience, I find it really hard to move. A lot of people who are native tend to be, or still are, believe it or not, C with classes or C, void star, et cetera, et cetera. And I find it very hard to move people that I work with or that I've worked with in the past towards a more modern idiomatic style. And things like Bjorn's new book or all of your work, this conferences like this help. But in your personal experience, convincing that void star guy to move forward, what are some of the things you do? How successful have you guys been in your personal experience?
It's immensely difficult, that's all I can say. And you have to think in terms of years or even decades. And you have to remember that what you call the void star guys tell each other what works and doesn't. And therefore, quite often refuse to learn new things because they know they're complicated, slow, can't be debugged, can't be tested, all the usual thing. You can sort of list what people object to. And the only thing that I found really useful is somehow figure out what a problem that the individual you're talking to have that can be solved better with C++, and then actually do it for them. And then sometimes they actually believe what they see. But there's a strong mechanism in the language world in you already knows this stuff what doesn't work, so I don't have to try it. And that's the mechanism you have to, that's the sort of psychological mechanism you have to break.
I find that that's very true. It's before saying, well, you should use C++, first ask, that's respectful, and it's useful, to say, what are the difficulties you find, what do you like best, but what are the difficulties you find with what you're doing now? Let them tell you why they need C++. Then you can show them how it solves their problem. Was that, and you had your hand up too.
No, I had a completely different angle. Whereas, while I definitely agree with Bjarne's and Herb's point, there's two things I would like to say about this. Number one, I don't want to sound like a marketing pitch for my employer, but at Facebook we don't have this problem. I swear to God, the day GCC 4.7 got checked, in, everything is supported was committed to the code base. There's a trickle of lambdas and Veradig templates and whatnot, and so there's very very bright people and very very good who actually can't wait to actually use these new things creatively and gamefully. Which brings me to my point. You're in the position of choosing your job. This has been for many decades already and continues to be a métier in which you have the luxury of being paid for what you love to do, essentially being able to choose your job. If you find yourself in a place where you can't move things, you could just choose a different place to work. And second thing I wanted to say about this, but I did notice works for me personally, is personal example must be there. If you go there and you show that you are more productive with whatever you know than other people, whatever they know, then that is the best way to convince them to try whatever you're doing.
I'd like to say that the problem is so bad that the people come out of high school with a void star attitude. They come out of high school, they think they know everything, they think they know what they want to do when they grow up. They want to write games. And void star is the most efficient way of writing games. They just know this. And if a professor says something obvious, then obviously the professor is not with it. And there are many, many ways this shows up, and in each case you have to figure out what is the individual's problem and what can you do to help it. And sometimes the answer is C++.
So I don't actually have an opinion directly on this, but I do want to share a story because this came up, and it actually comes up a lot in people that I work with. And it turns out that I went to a group because I couldn't believe that they were actually claiming the things they were, because it turns out if you ask them enough questions, you can get them to break through the marketing stuff about Void Star and actually explain what they're really thinking. And it often comes down to very simple misunderstandings. And once you ask enough questions, I kept asking. It turns out that he was like, look, this is performance sensitive. And in the past, I've been bitten by copying objects. The reason why I'm using pointers everywhere is because once upon a time I was bitten by copying objects. Now I need to use, and so I switched to using pointers, and that works, and that makes it fast for me. Right? Now he has personal experience with it, and the only way to counteract that was actually to go further. I was like, okay, so performance is what matters. How can we make it faster with C++? Not just as fast, but faster by using the language. And worked with him to figure that out. And one of the great things about this is whenever people say like pointers avoid copies, I like to say pointers also create aliasing problems. They slow down your binaries. They do not speed them up. The fewer pointers you have, the better your aliasing understanding is, the better the optimizer is about reasoning about your code. And one of the great things about this that's somewhat lucky for me is if you work on an optimizer, you can win this argument by writing code, by compiling it, and by showing them the machine code and stepping through it. And that's actually a really effective way to change people's minds. If you ever find yourself in that position, and I did, gather an audience. Because that exchange is what's going to convince people, right? Gather an audience, work through it, dive in, and then you can really convince people.
You also, you don't need to be a compiler dev to do that. Just use your compiler's option to omit assembler. And if you know assembler, great, you can point out, hey, this is omitting better code, or at the very least you can show, wow, this is emitting a lot fewer instructions. I don't know what they are, but it's a lot less. But that's sort of me, because I don't really know assembler, but I know a bloated code gen when I see it.
Two.
Benchmarking. Yeah.
Quite often the experience
Guess
that make
not.
people shy off from modern code is 10, 15 years old. They used a sort of 2.8 version of DCC, which couldn't do optimization if it tried. It's much better today, but the point is that somebody got bitten 15 years ago. Not only will he not, it's almost a guy, not touch C++, he will, in the strongest term, condemn anybody who even try.
Yes.
Some of these guys are very famous.
I feel like trying to. I feel like trying to.
Nope.
Okay. I feel like trying to repurpose a Reagan quote, which I barely remember, so I'll probably get it wrong. But it's not that our C friends are ill motivated or don't understand. It's they know so much that isn't true.
Yes.
Two.
So that's the Mark Twain version of it. It ain't what you don't know that'll get you. It is what you think you know, but it just ain't so.
Hi there. I just want to raise a question or a concern about the shared pointer. Isn't having reference counting being your mechanism for scope management fundamentally flawed? I just want to point out a scenario that I encountered that I think probably many people are familiar with, is that when you have one object that's referencing another and the other object is referencing back to that object, is not the deadlock that trying to do an unbalanced release to have that object released, is that not far more complicated than defining the ownership of which object actually owns the other object and is responsible for deleting it? And if we make that part of the fundamental language, are we not going to possibly lead people into that sort of trouble?
So yes, shared pointer doesn't deal with cycles. So the usual answers are, remember in C++, most of the time, you have objects embedded by value. An A owns a B by construction because it's a member. You've tied their object lifetimes together and you don't have to worry about it. Now, sometimes you do have objects floating around and you don't know in advance who's going to own them. Then that's when you use shared putter to share ownership. So first of all, limit it to that case. Then use weak putter if possible to break cycles. Then you'll get the deterministic release. But the deterministic release is really important, and it's something that managed developers who understand the problem envy. Having said that, yes, there is that one thing to watch out, and that is the one weakness of reference-counted shared putters.
The nerdy way I put that, that makes sense to people with CS degrees, is that ownership is a directed acyclic graph, and things like X is an object containing a Y, or X has a shared putter to a Y. These are the links in the DAG that say this owns something, and it's impossible for something to own itself. There you're asking for a leak. So to have something having a shared putter that has another shared putter back, that it means that you're not thinking about the structure of your program. And yeah, you use weak putter to break the cycles, but it's not like you're using weak putter as a hack. It's you're using weak putter to express the guarantees that were already there in your program.
I think about it slightly different. I would like to have objects with value semantics optimized by copy. And inside they may have some pointers, but they'll be nice vanilla pointers most of the time because they are just internal to an implementation. If that doesn't quite work well enough, I see, because I have to pass a pointer around, I look for a unique pointer. You can pass them by value. There's for us to pass as an ordinary pointer. They just have a decent release semantics. Only if I can't figure out the ownership do I go to shared pointers. Shared pointers are there if I can't decide whether you or you actually own the thing, and you have to sort of have a treaty about who does it. And you use a shared pointer to settle that. But shared pointer is not my first choice, it's my last choice.
So there's one common pattern that I see that actually yields shared pointer and doesn't yield bugs, and it's not subject to cycle problems either. And that's when the only reason for using shared pointer and ambiguous ownership is due to lifetime constraints. If you have two parties which have their lifetimes pinned by external constraints, right, and they need to share an object, a shared pointer may be the only effective means of declaring ownership there. That's very rare, but it does happen, and it's incredibly important that you have an effective means of supporting that. Often when you end up in this situation, the shared thing is very, very expensive, And the whole purpose of splitting into these two different lifetimed objects was to allow them to not duplicate that expensive entity. You see this a lot in user interfaces in particular.
He said with many more details what the example I was thinking about.
I'll try to answer the question directly. So the question was, what? No, because the direct question was, don't we want to encode in the type system the ownership relationships? And these were not direct encoded in the type system. The truth is that this is a solved problem in research. So there's a significant body of research on ownership systems that are enforced during compilation in the type system. And essentially, they have good guarantees. They provide expressive enough patterns of usage. The only thing is they're rather, let's say, slightly unusual. They're new, and the user is required to do a fair amount of annotation, to add a fair amount of type annotations to the respective pointers. So if you look at that body of research, you see this is not something that your C++ programmer is going to be expected to grasp and use on a regular basis. So I would say it's a practical issue more than a theoretical one.
By the way, it's also language neutral. Because as soon as you have this DAG of objects, Stefan's description is language neutral. This is how you're true of any program in any language that has objects and manages them, and there's this ownership DAG. In managed languages, which tend to say, look, we've got this great garbage collector, which is for raw memory, not for objects, not for resources. It's for automatically managing lifetime of raw memory, not the objects. They say, oh, but we automatically break cycles and do things. Right, that's why finalization is unordered. So the problem still exists. It just has, in some ways, weaker or at least overlapping strengths and weaknesses solutions. So the problem exists everywhere, and you have a choice of points as to how to attack it.
So 3? 3's been waiting for quite some time.
Yeah. Const.expr supports a very small subset of C++. For example, if I have a constant expression and it's calling a function, that function can't use an if. And so I wondered if there's any plans to expand that.
Not by me, and I'm one of the co-designers of const.expr, and I think people have already tried to turn them into a super macro. One of the comments from the academic looking at the academic paper about it was, why don't you just use an interpreter? Then you can get everything. And basically, const.expr is an engineering trade-off between what can be done cheaply, effectively, generating good code in the compiler, understandable by users, and expressive power. It would not be too difficult to give you an if, but it wouldn't give you very much. We could give you a loop, but then we have to be very precise about what happens with that loop. And maybe we'll get some extensions in the future, but I have the suspicion that maybe we don't need very much more, and that getting something significantly more would bring too large part of an interpreter into the compiler.
So I want to say, because we're implementing const.expr in Clang right now, I fear greatly the extension of this feature. Also, we have if, because you can do conditional operators.
Yep.
And so we've already, I know how hard.
We have loops because you can do recursion.
You can do recursion. I've seen a very short, very succinct in-Queens implementation in const.expr. Okay, it is that powerful already. The problem is not making it more powerful. The only extensions that make sense to me right now are ones which allow you to naturally write a function which is either const.expr or not, and efficient in both cases. Right? Where it's trivial to make it const.expr, it's trivial for it to not be const.expr. Currently, at times, the const.expr version, if you were to execute it, would be insanely inefficient. It would be nice if we didn't have to write functions twice. That's a noble goal. Trying to get more syntax or more expressiveness, I don't think we need it. We can already express things that terrify me in const.expr. It's worth noting the complexity of implementing const.expr is not just the complexity of interpreting it. You must diagnose it. And you must diagnose it accurately. And you know, in Clang, we like to think about diagnostics. Not only do we have to diagnose it, we have to trace back through the execution path that led the user to do something bad. And that becomes very challenging very quickly. And so the amount of memory expended to retain the state is very problematic. Extending const_expr is very risky in that regard. We've spent more time on const_expr than variadic templates.
You just partly answered what I was about to ask you. Just with your experience, roughly, you know, breadbox size, man-months, how big is const_expr to implement? You know, roughly, have you found?
I'm not the one implementing it, but Richard Smith has been working on const_expr for over 6 months now, I think.
6 months, man.
Richard has?
Yes. On and off. I don't know about full time. He's not here. He's going to like correct me. I'm going to be wrong. I can tell this now. But we're not done yet. All right? It's that hard. It is harder than variadic templates. I believe it is actually harder than lambdas. It is one of the most challenging to implement correctly features in the entirety of C++11.
It's interesting to note that it's one of these features that was made more complicated over the dead bodies of its proposers and initial implementers during the standardization.
Say, Charles, can we take some of the tweets, especially ones from earlier? So, for our panelists, when can we expect postponed features like reflection to be standardized and appear? Bjorn, do you have your finger on the pulse of things? And
I don't know. I'm not even sure what reflection is that has been postponed. I don't remember. I mean, there's compile time reflection, which has never been proposed, and there's the runtime reflection, which has been discussed several times, but we backed off because we would have to formalize too much of C++ as a data structure. That was for 98. There is a proposal for simple runtime reflection coming up, and I think there is a proposal for some more compile time reflection, so we'll be discussing it next week. But I won't give odds on how long that takes. One reason is that Herb says we should have no major features in the next release, and that makes a lot of sense. I say that maybe we can have one, and I doubt the committee will be able to agree on one as opposed to a whole lot. So I said, don't hold your breath. It will take time at minimum, or it might take a long time. It's a major feature.
Hello. Chandler, Richard reckons it was about 4 months so far, but close enough. This one's for Herb and Stefan. The difference between pass by value and pass by reference and our value reference from the examples in both your talks.
So what's the question?
Oh, the question was, Herb, you said that passing by value was premature pessimization.
Was that the one with his shared putter that was in red? I actually
Indeed.
wanted to comment on that, and I didn't get a chance to. But hey, look, now I do. Do you remember in my talk where I highlighted the move semantics in green and said, hey, this is the secret one where I'm going to modify the string, and then, hey, it makes sense to pass by value. And then Herb said, okay, always pass your shared putters by const_ref. I can never think of a case where I want to pass shared putter by value. And actually there is, and this was taught to me on VCSig by someone else. This is how I learned of it. I forget who taught me this. I would have to go look at my email archives. Imagine that you've got some function taking a shared putter to some t. And what you want to do with it is you maybe want to dereference it, but then you want to go push it back into a vector of shared putter. So yeah, you could take the shared putter t by const_ref and then do a pushback. That's going to copy the shared putter. What if instead you take your shared putter by modifiable value and then you say pushback move sp? In that case, you get either a copy and then a move, or a move and a move. It's the exact same case as in my slide, where you're avoiding an unnecessary copy when the source is already an R value, perhaps returned by make shared. Yeah, you do incur potentially 2 moves, but those are just pointer twiddles. You get 0 interlocked increments. So really the guideline, and Herb's absolutely right, we're still figuring out the guidelines. But I would say at this point, if you're intending to do pure observation, where you're only inspecting the thing, then take by const ref. But if you plan to do something that involves modifying, whether in my example where I'm modifying a string by value and then returning it, or if I potentially want to go move it somewhere, like or copy, it could make sense to take by value and then modify that value, or do a move, which is also modifying.
That's an interesting case, so thank you, as we're all learning this. Thank you for passing that along.
I'm getting
I
more-
think if I update my slides, I'm thinking, how do I do it? Do I just say, in a few rare cases without explanation, or do I add a new slide saying, okay, now there's this corner case that may happen, and here's a full slide explanation for it?
I would subtitle it, and so you want to be a library developer someday. Because really, if you incur an extra copy, it's not the end of the world, unless you're in an inner loop where it really matters.
But I'm really confused. Maybe I'm getting something wrong, but this is really old news. If you want a copy, you better. If you want a copy in your function, whether you want to escape it, in the case of shared pointer, or you want to mess with it, as in the case of Stefan's, I'm going to mess with the string a bit and then return it, or you want to swap it with whatever state you have, then you better take it by value in the first place. It was in Mojo like years ago. It's in C++ condig standards. And Herb, you forgot about it.
No, I didn't forget. I didn't forget about it. I knew about it. I was waiting for you to say it.
Destroy.
It's.
It really depends on move semantics.
It is not, and this was before move semantics too. At the time, you might remember that each time that it was mentioned, we said yes, it's right. It would work. It is not controversial. It is not uncontroversial, but that is good advice, and it makes the code unusual and more difficult for developers to understand.
Right.
So
but the old
reason.
unusual is the new usual.
that may be
negation of
true.
the negation. What's that? The Hegel's, dialectics.
I'm getting more and more worried about shared pointers, and I think you guys are spending too much time with them, and maybe you should spend a little bit more time figuring out how not to use them.
I think I was actually
or how to use them very simply.
This is not about shared pointers, though. I mean, shared pointers exacerbate it, but it's any object.
String, like in my example.
If you want the value, better take it by value.
And I think actually Stefan had a great observation. If you're only going to observe the value, if you're not going to change it, send it somewhere, destroy it, move, like anything you do to the value, like when you're doing something with the value, always take it by value, because you need the actual value. If all you need to do is see it, that's when you want a reference. That's when you want a const reference.
Yeah. Great.
Great. Number 2.
A practical question, mostly for Herb. Libraries, the lack thereof. There might be some people here and some people watching online who are able and willing to help close that gap, but who also want to put food on the table. What sort of advice would you offer those people?
First, please email. Let me know. If you are a zlib, thanks for mentioning that one that I forgot from my slide, Boost, Adobe, Apache,
Poco.
Apple, Poco, yes, I had that one on my slide, and so forth, developer who has access to in-house libraries that, that could be contributed or just want to help, and please let me know, because that's what we're trying to put together. We have a spreadsheet with the list of the features we want. Only half of them are filled in with existing practice, and smaller than that with people who are able to contribute work on them. So if you have time, it is not expected to be a full-time job, but it does require help. And so that's the thing we need most, is expert help. I happen to know you fall in that category, so I'm hopeful to pry away some of your time. Thank you for offering.
The other half of the question was the food on the table part.
Well, that's why I said not full-time, because food on the table, it's unfortunately standardization, believe it or not, is a volunteer effort, and companies like Google and Microsoft do contribute much of our time to do it, to move it along. And other experts come on their own dime, as you know, and they contribute from their own free time or their own work time they take away from whatever else they were doing. So it's all volunteer effort. It's interesting to see this kind of project and how much has been done in C++11 on an all volunteer basis. And people who say, well, why didn't you design this completely and why didn't you do this whole, don't always appreciate that.
No. And I mean, they say, well, why don't you treat it like a proper project? Okay, you have project management and you just follow the schedule. Look, how do you do a project in the traditional way with no reward structure, no punishment structure, no way of keeping people there, no way of assigning work, no way of kicking people out when they slow things down? None of this is available. We are herding cats, and we may be considered very good at it because we are delivering, maybe not quite on the day you would like it, but we tend to deliver reasonably good thing in not too outrageous timescales.
I have an idea for punishment structure. The next person who tries to add something to const expert, they get to maintain the IO streams wording. Just give it to them.
So Herb, can you read the question from Twitter?
What is the plan for modules? What problems make them complicated to have? How will they be solved? Anyone want to? We talked a little bit about it yesterday, but
I'll wade into this one.
Yeah. Sure.
We don't know what modules are, and so it's hard to have a plan for them. We have competing ideas of what modules are. I think we have to figure that out first. The problems that make them complicated to have is that I think modules are going to inevitably be one of the most syntactically invasive changes to the language, because unlike a lot of changes, you think about changes to the syntax, right? We like changes that are inside the syntax, right? Because they're easy to kind of incrementally grow. Changes to the outer edges of the syntax are really far-reaching. If you imagine like changing the syntax is going to impact every declaration, that's really, really invasive. And I think all of these things kind of combine to make it an instantaneously heated discussion. And I wish we could keep the heat away until we actually figure out what we're discussing. Because I've heard at least 4 different problems, like capital P, problems that modules are going to solve, and at least 2 of them are mutually exclusive. So it's very, very confusing to even talk about modules. I think we need a lot of time and thought before even. There's no plan.
I agree with that, and I'll say that's actually a more general problem than modules.
True.
When people come and they want X, doesn't matter what X is, everybody thinks about X, of what it solves for them. And as soon as we come down to a concrete proposal for X, we'll find that it actually is not the ideal X that you were thinking about, and you were thinking about, and I was thinking about. It's sort of a concrete thing that almost does what I like, but not perfectly. And at that point, support for X drops. Sometimes for 2/3 of the people walk away in disgust because it wasn't their X. And modules suffer for that, at least to a large extent, because he said those 4 variants of it, and I think the number is conservative.
It's probably growing as we're talking.
Yes, and people expect so much and mutually exclusiveness of modules that it's a very tricky issue to deal with.
Fortunately, world peace is not one of those problems, and he plays in the NDA now.
Yeah, at this point in time, you never know.
One.
Why didn't move semantics pass into lambda capture? For example, it is impossible to pass a unique pointer by value.
I asked the committee for that. They said it was dangerous. I disagree still.
You can't pass a unique pointer by value?
No, because it would attempt to copy.
Yeah.
If you try to say bracket UP bracket, that's going to try to copy the unique footer, but it's non-copyable. You can capture ref to unique footer, but that doesn't move from it.
Yeah.
Oh, why can't you just move it?
Yeah, I would love to be able to say bracket ref UP.
That's what I thought it was doing. Well, sorry.
Yeah. Hey, you got to vote on the committee.
So that's what it does everywhere else. But this is an example of where we've got a pretty high quality standard, but we still need to work out some interactions because the committee was conservative. We wanted to ship. Shipping is a feature.
Yes.
Anybody who works on a product knows this. It was very close, by the way. C++11 was this close to being C++13 simply because a lot of people said, well, let's just have one more ballot, which in ISO means add 2 years. So a lot of us fought against that and prevented it. That's why we have C++11.
Yeah, so
but you need to ship.
If we get just another couple of months, or just another couple of meetings. It'll be perfect.
So one of the things that we are now going to go back and do is say, okay, the things that we weren't sure about, because including polymorphic lambdas, which were discussed, but we weren't sure how they interacted with concepts, and then concepts left, but it was kind of late, and things like R-value move capture, those are things that we need to start talking about again to finish the fit and finish, the polish of the interactions in C++11 features. It is better, by the way, this is a good place to be. It is way better to have, in the language side of the field, not so much library, but in language, to not have a feature than have it misspecified and that you have to support forever. And then you've taken that hole and you can never get a chance to do it right.
3. Hi, thanks gentlemen for coming and doing this. We really appreciate it. I'm new to cross-platform development, and this is a bunch of experts in a variety of platforms. Can you share some tips and tricks for managing projects and using multiple compilers and a lot of these other things for getting C++ code to compile across many platforms simultaneously?
Let me just be the first to throw in, isolate your compiler and platform-specific stuff in a single platform.cpp or module as much as possible, and then write portable ISO C++ everywhere. Everybody's going to tell you that.
Yeah.
But isolate it. That includes all Microsoft extensions, including C++ CX. That includes all GCC extensions. That includes Solaris extensions. Well, anyway. So
you had to go to Solaris.
But definitely isolate that. And then you have your 95% portable code, and then you just re-implement this for each new compiler or platform. Isolate yourself that way.
And compile everything with all the compilers often.
Yeah.
Don't get it to work on one platform and then port. That's the wrong way.
It also helps to avoid extensions that aren't absolutely necessary, like VC's 4 space each. I viewed as very bad because A, it was not portable, B, it just replaced, a handwritten iterator loop, which is more verbose. But is that really worth the cost of non-portability plus a fragile extension? Extensions often tend to be not nearly as well tested as portable code that the whole world is going to constantly test every time they use it. But if it's an extension that buys you something like decal spec DLL export, and if you want to use a DLL, then okay, use that.
I'm going to jump up on a very tiny soapbox and say, I think one of the easiest traps to fall into when dealing with this is to think that your build system will save you. A lot of people like, especially in the open source world, we have configure scripts, and our configure scripts craft portable bits of code for us, and our make files are enormous and pull things together. This is a trap, and it's a trap laced with very dangerous toys. Okay, don't go into that trap. There are easy ways to write your code in a portable fashion, even when you're writing the code in the isolated part of your code base, and it is isolated, which has to deal with platform-specific dependencies. Every single platform I have ever touched has preprocessor macros that the toolchain provides, which clearly and specifically identify that platform. You don't need any scripts to get these. You don't need any generated files to get these. They always show up. There's actually a great database online you can go to. They've collected all of them. You can target platforms from HPUX across Solaris all the way through old versions of Windows, new versions of Windows, weird versions of Linux. Don't let yourself be fooled into the popularity of build systems. There's a better way. And it's in the language, and that's why it's better, because it's actually in the language.
Great. Number 2.
First of all, thanks for all the speakers and the respective companies, and special thanks to Microsoft to make this happen. There is a saying I like, and I don't know if the translation will be correct. No one is prophet in his own country, or company for that matter. So you guys can be prophet in my own company. There are people at my company that believe that STL is somewhat a third-party library and that has portability issues.
What?
Yeah. And therefore must not be present in APIs. So STL is a bad press in my company, and in my opinion, a large underusage of classics like std vectors. My question is, are they right to consider STL a third-party library? And if not, how can I convince them of the opposite? Thanks.
Let me take this real quick. 14882:1998 . It's an ISO standard, has been for over a decade. Go ahead.
That was easy.
I feel like I need to hold you back.
Show them the ISO standard.
They all start with STD : That's a hint. It's not like third party or like janky software : I don't know. Like,
it used to be the case that compilers would not ship with standard libraries, and you would have to graft on something else like stelport. But now every compiler comes with a homegrown implementation like VC or GCC's libstd C++. Kling's got a libc in development, I believe.
Yep.
And it's many users don't even realize it's a separate thing. To them, it's just part of the language, and they are built to be the absolute highest quality.
I mean, it's about 14 years since it became standard and started shipping with everybody.
Andre, next time I will not do that. But please say what you were going to say.
No, I was just 2 words for him. Contact headhunter. It's not the fight worth fighting.
Now having said that, some people, this is not it's not a third-party library, you should use it, but when you said in interfaces, like on module boundaries, remember, all C++ class types have trouble there. Yeah. So it's people talk about why can't I put string on a stinking module boundary? Well, because you're sensitive to implementation, and that happens to be the one with the most variable implementation in the whole standard library. So that might be part of what he's saying. Other than that, Andre's advice is good.
Go for it.
So when considering new language features for inclusion in the standard, how important are compiler vendor concerns and the availability of existing implementations? And were there any compiler vendor concerns about C++ 11 features? And what happened to export in that case in '98?
Whoa, I'm not going to start with that one.
Yeah. Next question.
Well, maybe I should say something about this because, well, I don't have any opinions on it, do I? Anyway, I think de facto the compiler vendors and the library vendors have a veto power. And in many cases, they are very conservative in what is accepted. There are some that are so conservative that the language wouldn't move at all if that was the case. So if you're worried that things are pushed in over, now I think that's a conservative body and they have a major say in things. Export was a compromise, and it turned out to be not a good compromise. Some of us wanted separate compilation of templates, others didn't. And the compromise was probably worse than both alternatives. The compiler vendors that implemented export eventually decided it wasn't worth it, and they proposed a withdrawal. The EGG implemented export, did it very well, very professionally. They then proposed that it be removed because it was a burden to them and to the community, and vetoed attempts to just deprecate it because that would still be a burden. They wanted it really gone. And I think it was the right decision.
And EDG are heroes, by the way.
Thank you, EDG.
Because Edison Design Group, always been long the most conformant C++ front end. They don't have the complete compiler, they make the compiler front end. When export was being debated, every single compiler implementer argued strongly against it. It went in including EDG, and even EDG led the charge against it. It was voted in anyway, and they spent 3 man-years implementing it. That is honor.
It wasn't 3 men, it was 3 David years, okay? Yes. That's different, it's much more than that.
And so we gladly deferred to them as say, look, you're the guys who did the work, we'll do whatever you say. And they said, look, it's better for us if you just yank it instead of deprecate it. So we said, it was unanimous.
Let's go to 2, or not?
No,
Please talk.
Go ahead. Oh, okay. Also, in other cases, we clearly went out of our way to support all the different vendors to make sure that nobody was severely handicapped as a result. So that's actually fairly apparent if you look at the atomics definition in the standard. There are various low-level possibilities there, which are intended to ensure that basically you can write very efficient code for every possible vendor's current implementation.
So do you have any advice or strategy for companies who have to support a very cross-platform, very wide range of possibly very old compilers like Visual Studio 2003, that the likelihood of seeing a C++ 11 feature actually in production use is possibly years away? Should the language have offered something so we could like if-def it in, though that even sounds kind of ugly? Or should I just throw up my hands and say, I'll come back in 2016 and I'll think about C++ 11 then when I've retired all those old compilers?
It's very hard to fix problems when you can't touch the compiler technology. Mm-hmm. If people insist using a 10-year-old compiler, well, you're using a 10-year-old language, and you'll have to consider whether supporting that system is worth what money it brings into your company compared to the cost it imposes on you for being unable to do better across your user community. It's a commercial decision.
3.
I think this is another time when his mantra kicks in. You should ask yourself, like, why?
3 is a bit of a low number.
Right? Like,
although I should point out, I remember in Herb's slides, he mentioned that external templates are supported in VC10. That's actually not true. They were originally supported in Visual C++, I believe 2.0, John Case told me, which is... So you have external templates. Hey, hey. That's a C++ 11 feature. 1911.
Having said that, 2 of the compilers that stuck the most, which, yay, they got great adoption and traction for C++ developers. Unfortunately, then people got stuck there, were GCC 295.3 and Visual C++ 6, which as of our previous release was still our compiler's biggest competition from 1998.
3?
Number 3.
Yeah, I'd like to go back to the keynote and the question asked there about what is the greatest weakness of C++. And the follow-up presentation with Clang kind of teased around the edges of this. And to be completely fair, I don't know that it's a weakness of the language, but in the application of the language. And that is the single-pass preprocessor and having to fully declare or define objects before using them. And the result of that being a dependency graph in your includes. And woe to the programmer that ever has to change that on a very large project. And this is really work that you're doing that doesn't ever express the ideas. It's basically maintenance work that you spend many, many man-hours dealing with. I was kind of curious if there was any thought put into that.
Yeah, so I have a lot of answers to this. I have at least 2 answers to this. So the first one I want to answer is the idea of single-pass preprocessing and linear compilation. And this one I'm going to answer from the perspective of a compiler implementer. And when you're implementing a compiler, I really want those, and for a surprising reason. So I'm glad you asked this, because this shocked me when I understood this part of Clang's implementation. It is crucial to the performance of the compiler that the preprocessor be single pass, that the compilation be single pass, that it be forward moving, and that you preprocess as you parse, because of cache locality. By doing single pass compilation from the top down, you ensure that every semantic structure you are most likely to refer to, every AST node you're most likely to query, every token you're most likely to manipulate is almost assuredly in cache. The compiler is much faster because of this than it would be otherwise. One of the slowest things to do in Clang is to do tentative parsing, large amounts of tentative parsing, because that disrupts this single pass parse and it loses your cache efficiency. I was stunned by how important this was to compilation performance. To give you an idea, when you don't do tentative parsing, when you don't get any of these weird scenarios, and template instantiation, templates are not one of the weird scenarios, like keep that in mind. As long as you're not in that situation, parsing C++ is almost as fast as decoding a binary representation of the AST off of the disk. All right? That is shocking to me, right? It is as fast as just reading a data structure because of the cache performance. So be careful if you want to break that up. Now, there's a second question in there that I think is a more interesting question for users of C++, and that is how do you deal with the frightening problem of managing header files and include management and the dependencies that those form. I think that there's a really great way to manage those, and that is to let entities that are much better at graph manipulation than human beings manage them. We should write tools that look at all of your header files, look at all of your source code, and they just tell you what your include should be. Better yet, they actually just write your includes for you. There is no reason that human beings should be involved in this process other than to answer disambiguation queries, right? Like, did you mean this header file in that directory or this other header file in that directory? A human being's useful there. Short of that, it's not necessary. We can do this for the users, and we should be developing those tools. And actually, we are developing those tools on top of Clang. We really want to have tools that can manage completely the problems of selecting and managing your include ordering.
It's not just oh, you go. Your turn. Your turn.
I opened my mouth, so I got priority. I gotta take issue in the strongest stance with the first part of channel sensor. I'm sorry. It's the whole assumption is based on the idea that you do parsing and compilation on a single processor machine. The fact that the semantics of everything is dependent on everything that was just before is, in my opinion, completely bankrupt. We must think of compilation in terms of parallelizable process and the way these impositions made by the pre-processing step, which is for its power, it's so complicated. It's not even funny. There's so much work. All the damn trigraphs and all of even the backslash. The backslash continuation line thing, it's eating like 2% of your compilation time if it's not there. It's kind of crazy. So the ideal language and the ideal compiler would be parallelizable in compilation, meaning every symbol is entered conceptually in parallel, and there's a simple process of constructing
I think I agree that the preprocessor is evil, but I think taking away all context sensitivity is just downright impossible. Yeah. And a module system might help, depending on what the module system was, but it's not the individual function that's self-contained. It's something much bigger than that.
But Andre, I destroy you.
Destroy.
I think it sounds like you're talking about within a translation unit. Yeah. We do big projects. It's naturally parallelizable. Yes. Distributed builds are already being widely used for C++ using third-party tools. We ought to ship some, but we already do parallel builds in our compiler. Having said that, the order dependency issue, I think, that matters more, when I thought you were going to say, to users, to understand their code, not even the include stuff. It's just, void f int. Call f with 42, dot. Void f double. Okay, which one do I call? Oh, the one before. It's order sensitive, right? That's one of the usability, small but important, potentially usability. Small, tiny, fractionally usability benefits. Now, having said that, so that's a usability benefit. The trouble is, as soon as you go beyond a one-pass model, you do not go to a two-pass model. You don't stay there anyway. Does anybody here happen to know? I don't know the answer, so in case anybody in the room knows, how many passes are in the current C# compiler? Anybody know roughly? I think it's in the mid-teens, but I'm not sure. Because the problem is, as soon as you have multi-pass, you tend to want to solve things by adding another pass. Then you get ordered dependencies between the passes. This is a real problem. So
the compiler is so much faster than a C++ compiler is.
Wait for it.
And their generated code is so much slower.
Repeat the point, actually.
Backends are typically multi-pass, though.
Yeah. Backends multi-pass. Yeah.
All right, let's go to one.
Can't help saying that when discussing the best ways to welcome void star guys to the warm and fuzzy new C++ world, the advice lead by example sounds the best when it's said by Andrei Alexandrescu.
Thanks, Mihail. Thank you.
My question is about concepts. Could you please go into a little bit more details about specializing or not allowing to specialize concepts based on other concepts?
So you want to have a concept that you specialize based on some other properties? I think that issue came up when we were hashing out some of the details of the concept report, or the technical report, and we decided that it probably wouldn't be a good idea to allow it for the time being, because you get into this interesting situation where you have a concept that says, here you have these requirements, which is a good start, except when you have this set of types over here. Then your requirements can be relaxed or they can be weakened. And you end up in a situation where you require something, but you don't actually know the concrete requirements of what you've just said. So you require, I don't know, a monoid, but for some sets of types, we can go ahead and relax those. And you've completely bankrupted the original intent of the concept accidentally. So we haven't supported that because we haven't found really good use cases for it yet. We can overload concepts with different numbers of parameters, but that's not getting in a case where you're actually replacing the meaning of something that you've already specified.
We're aiming for a radical simplification over what there was before. It more or less guarantees that there's some things you could do in the past that you can't do with what is proposed, and that's the price to pay for simplicity and faster compilation.
So let's go to Twitter, and then we'll go to 3, who's been waiting forever, and then we'll go to 2.
I'll do a quick one. Where do you see C++ in the cloud? See on Channel 9, the C++ AMP keynote, and that's my answer to it.
We have Microsoft, we have Facebook, we have Google. Where do you not see C++ in the cloud?
It's out there.
But to be fair, he's probably talking about cloud computing and the whole thing when we call it the cloud, not necessarily infrastructure back-end services like search engines and whatnot. So Herb, you should probably explain a little more for people who haven't seen it.
So there are two parts to it. The part I referred to, and just very briefly, C++ AMP, the idea of heterogeneous computing, local or remote. So today that's GPU, which might be not shared memory locally, right? That's pretty normal. So you can imagine that extending that model to heterogeneous processors also distributed. So that's the evolution of the cluster. So that's how do I take this computation and spread it across lots of compute devices, local and remote. So that's one aspect of it. The other aspect of it is, if I am already have some mechanism like Azure or Amazon Web Services or something like that to distribute my problem, I've got a queue I stuff stuff into, and everybody pulls from it, and then just runs locally. You want that local process to be as efficient as possible, and that's what's often written in C++ today. So those are sort of two parts to it. It's sort of a push versus a pull, but those are two of the major. Is that kind of what you had in mind? I saw you nodding.
No, I agree.
There's a question for someone, not Herb.
Yeah, Andre, will you read that, please?
Don't skip.
Let's take number 3 first. So.
Han. This is Han? Yeah. So I was really happy to hear that you guys were talking about, much larger library support, because that is often the first thing that stops me from picking up C++ for certain projects. But in a case where, in your example, an XML parser is needed, often the second thing I think of is where's the UI toolkit, et cetera, what's the tooling around it. So I realize platforms are different and are going to stay different, and OSs are different. But how, in constructing this library, are you going to sort of define that boundary and make sure that, if OS vendors want to go off and create totally new UI systems, WinRT for Microsoft or whatever it might be, that it builds on top of this, larger library? Is there support for something like that?
I happen to think that it may be possible to specify as a stretch goal, and I emphasize as a stretch goal, and not the first priority, a simple portable UI, which is not widgets and buttons, but just on the canvas drawing kind of level. That might be possible and interesting. But even if all you've got, and I put all in big quotation marks, is XML and sensors and SMS and HTML and cryptography, that's not so bad.
So we're going to go to 2.
Yeah. The question is for Andre, static if. For the template constraints for the functions, if condition fails, would it compile because it seems that the semicolon is missing in the end of the function body?
If the condition fails, what could you repeat?
Yeah, that's a template constraint for the function. In the case of a class, understand if the class definition body is gone, you still have the semicolon. But for the function, if the function body is gone, there's no semicolon, would it be compiling?
Oh, I understand. So the question, let me make sure I understood, was so you have the signature of function, and then you have the constraint if, open paren, Boolean expression, close paren, and then you have a close brace, and then you have the body of the function. And what you're asking is, what if the condition evaluates to false, in which case the body of the function vanishes, and you have a sort of a parsing error there, right? Is that the question? Okay, thank you. Actually, it's not. I mean, it's not as literal as I put it. So the body doesn't vanish from there. And I see Chandler here, like, of course. I mean, come on, right? So it doesn't really vanish. The condition evaluates to false. That doesn't mean the compiler forgets to parse the body of the thing and gets surprised when it doesn't find what it expected. So the body of the function is still tokenized and parsed to some extent at least, and then it vanished together with the signature of the function. So there's no danger there.
There was a question earlier that's gone away, but perhaps Hans, it would be a good one. What should be next for concurrency in C++?
Well, there are a number of things that are under consideration currently. There were clearly sort of relatively straightforward additions that were omitted in the first cycle due to time pressure. So, for example, we have a conspicuous omission currently of things like reader-writer locks, which currently we need to have there. There's a lot of discussion of task parallelism, which is currently conspicuously missing and was also omitted under time pressure due to a prior compromise. Some of us would like to see, in particular, I'd like to see transactional memory at least considered as sort of a longer-term goal. I suspect there are quite a few other things that will come up in this next cycle.
Thread pools, sorry.
Thread pools, right. Sort of, yeah, the whole sort of thread pools and task level parallelism area is one where we need to do work, but last time we didn't quite get it done on time.
We could either get it done or we could be on time.
One of them.
Right.
I think we made the right choice.
Yesterday you opened up the panel with the question of why C++, and I started thinking about the converse of that. Why not C++? And I love C++, and I love the ability, the power you've given us with the new features, but I am also concerned about those because I think about, like, right now the longest pull for me in development is compilation and build times. Our build takes half an hour on a distributed system. Do you think about features that will improve the productivity of programmers through iteration? I mean, if I choose another language, it's not tens of % of difference. Sometimes it's 2 or 3 orders of magnitude that we're talking about. And I would gladly give up 1% of performance for a 1,000% increase in build times.
Is that a full build or an incremental build?
Those are full builds. We don't really use
Are your
incremental builds are not part
broken?
of our process.
Or because then fix your build system. Then,
I think
by the way, all build systems are
well,
terrible.
I mean, there are lots of hacks people use. Like there are distributed build systems, there are compiler firewalls, there are Unity builds. I mean, we've tried all of those, but ultimately we fall back on. We're very concerned about reliability of our product, and we fall back to full builds, and they're just huge.
Okay.
Let me just acknowledge that this is the biggest problem Facebook has in its use of systematic use of C++. We have an extremely talented guy on who's build czar. He's doing an awesome job, and essentially still build times are a major hindrance for us.
So I just want to say we were in the same position about 4.5 years ago at Google, in that one of the challenges to using C++ pervasively was the build system and the necessity of a build system. And we ended up doing a very ground-up rewrite of the actual implementation. And I think we have good evidence now that we can build a extraordinarily efficient, extremely incremental, and extremely distributed build system. It's hard, like it's a ton of work, but it can be done. And I think that this is fundamentally not a language issue, this is a build system issue. No language is going to save you from the need to do accurate, reproducible, incremental builds. And I say this because we ended up reinventing our build system, and we didn't do it just for C++. We did it for C++, for Java, for a lot of other languages as well, because the same really exacting reproducibility requirements impacted all of the different languages.
Yeah, I would say maybe a concrete piece of advice: find your best, most talented person there, and have them head a build system team. Yeah. We have a team. Yeah. We have a great guy in front of it. It's just they do a great job at it. I think this is like 30 minutes is just unacceptable. You can't live with that. So just get a team together, put a great guy or person in front of it, and they're gonna do something.
I'm glad you said 30 minutes isn't acceptable, because one of the things that in Visual C++ we often struggle with release to release is you're always adding features and power. And if you take a dependency graph of all of Microsoft, like this team depends on this team and so forth. There are a lot of popular nodes like .NET. A lot of teams use .NET, and a lot of higher level and lower level nodes. And the only team and product that every single team transitively at Microsoft depends on is Visual C++. So we're either on the top or the bottom. I'm not sure which that is. But it means that every time we release, one of the many release requirements is Windows must build overnight. And so half an hour is.
Yeah.
half an hour is a problem.
Half an hour for one iteration is unacceptable.
Some of this is a language issue. I remember many years ago somebody came to me with the problem that they were about to take more than 24 hours to do their build. Of course, computers were slower then, but still, that was dramatic. And the first answer was the build system, and we couldn't fix the build system, so I looked at their code. And the problem was they were including everything in the kitchen sink everywhere. And I taught them about abstract classes used as interfaces, and he came back a week later and had 11-minute builds from 23 hours. So in some cases, you can be lucky that it's just actually incompetence that caused the build time. And one of the reasons we wanted separate compilation of templates, which we have never quite solved this problem, was that the header files were getting bigger and bigger, and people were not managing their header files. They were just including everything. And there's a lot in those. I mean, the ratio of information to header files to C files, CPP files, is just dramatically with more stuff in the headers. And some of the solution is only to compile what you actually need. Mm-hmm. And that's probably not fit for humans, to get back to that comment.
When I teach C++, I get a range of people from very advanced to seeing C++ for the first time or don't know the template syntax. And it's interesting. One of the things that I think is very basic, and I keep on every single time discovering that this is amazing to people, is forward declarations. I mean, they know about forward declarations, but let me give you this example. In a class, you have the following member function declaration: widget, space, function name, paren, gadget, paren, semicolon. So, returns a widget, takes a gadget. Do you need full definitions for widget and gadget?
Neither.
Thanks for the spoiler.
Did I say that out loud?
Yeah. Use your inside
we're amazed. We didn't think you could figure this out.
Sorry.
But here's the thing people think. They think, oh, I know that if I took a gadget ref, I'd only need a forward declaration or a gadget star. But because I'm taking a gadget by value, no, you're not. That's not a function definition. Right. You are merely saying, I'm declaring a name. There is a function named myFunction, which returns one of those, which is just a text string label, and returns one of these, which is just a text string label. If you do not have the function definition, you do not need definitions for those things. Forward declare them. almost every single time I see people coming back the second day and saying, wow, my builds are a lot faster.
11.
So try that, because there's a lot you can already do.
Remember when I was saying that we're working on a tool to manage header files? I misspoke. It's not about just managing header
It's about
files.
symbols.
You manage both header files and forward declarations. And one of the key things you can do when you automate things and you provide tools is you can actually mechanically go through, remove every single header file that's not needed, replace them with the forward declarations that are appropriate, and then show the user this is your new code. And that both educates the users, and it cleans up their code, and it makes their builds faster, and we can do this automatically. We can do this with Clang today, and it's a beautiful thing to see. We're working really, really hard to actually package it in a tool that we can just give to people and say, like, your include file's a mess? Run tool. Fix. Done.
And until you can do it, there are sometimes dramatic things you can do yourself by being aware of the problem and
as you use the tool,
solutions.
One of the important things I think is that this doesn't sink this information into a black box of a language feature.
No.
It surfaces it by writing it in the source code.
I
so
want,
that people see
I want
it.
the tool, but I want to do something today.
Yes, yes.
So there's
excellent. Chandler, Clang does try to do a great job at hinting the programmer what kind of errors he did and how to fix them. How do you think concepts will help here, and do you think they are really necessary?
I'm really glad you're sitting here. You may be less glad you're sitting here, but I'm really glad. Okay, so that's a really great question. I think this is one of the most interesting things. This is like modules. I don't think we know what concepts are, or even what all we are looking for in concepts. We know we're looking for some things. I don't know that we've restricted what we're looking for in concepts. If we think that concepts are going to primarily be giving us diagnostic improvements, I see compelling evidence from our work on Clang that they may do so, but they may not be necessary to do so. So they would be sufficient but not necessary. We have some evidence that we can actually, when doing when doing a diagnostic, we can detect a failure to instantiate a template. We can actually synthesize something similar to an archetype for that template, walk back up the instantiation stack, find the first point at which we believe the types started to mismatch, and tell the user about that first, and suppress almost all of the instantiation stack behind that. We can actually start describing the interface components that might need to be on a type in order to instantiate templates. We can collapse the different elements of the template, the actual template's type name, right? The actual name of a single template, to focus on the pieces that do not match properly. There's a tremendous amount of flexibility to actually make diagnostics categorically better here. That said, I am not at all convinced that diagnostic improvements are the primary benefit of concepts. And so it's not a good comparison, I suspect. But I wanted to answer this question with you here too.
Yeah. You didn't say anything that I considered particularly shocking or strange. We're working on concepts, and people have a tendency of picking one aspect easily explained and then use that as the reason. And the bad error messages have been the reason, and there's people who think that the reason we need to deal with concepts is bad error messages. Primarily, I would like to see a way of saying what I mean.
Yes.
That is, I want to specify an interface. I don't want to just have the implementation of a function being the definition of the interface.
Yes.
I don't like that at all. Given that, then we try and figure out what is a concept, how do you define them, how do you use them. We see what we get in terms of elegance of expression, in terms of complexity of teaching and learning, and in complexity of implementing, in complexity of writing the standard. And then we see what we get, is it worthwhile, given the cost.
Yes.
Now, I concluded very reluctantly, because I'd worked on it for 5 years, that what we had for C++ OX wasn't worth it. worth it. There were 70 pages of description of what concepts were. That was the size of the original C++ manual. I mean, that's not right. I mean, the original C++ had function argument checking, long before C, of course. It had classes, it had private, public, it had constructors, destructors, all that kind of stuff. Concepts is not worth as much as that. On the other hand, I'm hoping for an order of magnitude improvement on the complexity of the mechanism itself. I am hoping for significant decreases in compile time using concepts, because if we design our concept system well enough, a lot of the concept we're using, like regular, will be common to everything and therefore an obvious intrinsic in the compilers. Yeah. And then actually take away from the header files information that you would otherwise have to pass. But I told people here it's a research project, and a major part of my research problem is simplification, and once that is done, we can have a discussion of whether it is worth what it'll cost.
Now let's bring this full circle though, and back to the question, because the interesting thing I think is you've given lots of good reasons to pursue and to investigate concepts. But let's say we go with concepts. If that lets us make much, much better diagnostics, right? There's nothing bad about using concepts to improve diagnostics.
No.
Right?
I'm pretty sure that we will get it if we had concepts.
Right, exactly. So it's important to say that we can improve diagnostics without them. If we have them, we're going to use it. The same thing holds for static assert. Would static assert have been sufficiently valuable if the only purpose were to have a more clear error message? I don't think it would have been. But there are other benefits, and major benefits. Once you have it, you're going to use it for everything you can, right? And if we get concepts, we're going to use it for everything we can get out of it. Yes. And until we get it, we're going to try and make the diagnostics as ridiculously clear as we can.
My opinion is that if we get concepts, we will get better designed and better specified code.
Okay, I think cobwebs are growing on number 3.
Charles, I think we gotta take the someone not Herb question. But for the heck of it.
We will, but
all right.
But that's kind of.
Let's get the patience.
Let's let the number 3 say something.
So in this morning's session, Herb, I was the one who brought up the idea of syntax as a problem in C++, and you mischaracterized my objection. As I just didn't want to type a few more characters. I think it's way, way worse than that. So, for example, there are all these tools that haven't been written. Because if you want to write a really useful tool, the first thing you've got to do is parse the language. And there have been many tools I've wanted to write, and then I've realized I've got 5 years of work just to parse the language. I think it's great now we've got Clang and Chandler's talking about writing tools, and that's going to be fabulous. It hasn't helped me over the last 20 years. Bjarne, in the Q&A after Bjarne's talk yesterday, there was a tool that he'd wanted 5 or 6 years ago that still doesn't exist. So I think that's a problem, but with Clang, I'm hoping it's a problem with the past. But Andre showed us an example where the get function on the tuples was made a non-member function, because the syntax for making it a member function is just so utterly horrible we can't deal with it. And I don't know whether get should be a member or a non-member. There's a whole separate argument over that, but the point is the syntax stopped us from being able to make that decision purely on its merits. So, long preamble, there's a question. Is there any way out of this problem? Because syntax stuff, you really are going to break the world. I suspect Andre's answer will involve a language that we've kind of talked around a lot this session.
My lips
but
are sealed.
I'd like to hear the panel's opinions on whether there is an answer to this problem.
Modules.
There is an answer. You can improve syntax. It will involve defining the language in terms of abstract syntax trees, typed abstract syntax trees. And you're never going to get there because of the C culture in the community that defines the language in terms of the character sequences you feed to it. And I think the main problem is not actually the awkward syntax, which you can deal with. It's the fact that macros ensure that the compiler never see what you write.
That was what Bjarne said is roughly what I was trying to say. The syntax, and I apologize if I mischaracterized and oversimplified, the syntax is not the biggest problem, which I was trying to say. What's the biggest hole in C++'s story? It is not the biggest hurdle for programmers, because people sometimes complain about how much they have to write or the rules. I do agree it's a problem for tools. Frankly, of a certain kind of tools, those that actually want to manipulate the program. So the people who want to do source inspectors or add-ons, static analysis tools, that kind of thing. The biggest, even bigger tools problem, though, if you want to talk about tools, we need partial classes. Because you want to be able to round-trip compiler tool-generated code. That actually, I personally completely understand that you want to have better tools that manipulate ASTs. It would be lovely to get there, and a lot of people like Clang are working on that. But I think you'll find even larger bang for the buck, just being able to have round tripping and keep separate the tool-generated code from the user-generated code in the same class with something better than one of the usual solutions like comment, please don't edit below this line, comment, okay, now you can start editing again.
I don't have the mic, so I'm going to shout. My response to that is just, I wanted Clang 20 years ago.
Yes.
I'm sorry, it took Doug a while.
I wanted it 20 years ago, and I didn't, and nobody had it.
Tough luck. It's still a problem.
So I do want to say, on the tooling subject though, I want to clarify what the state is, because I specifically avoided talking about tooling in my talk on Clang because I was trying to give a much more language-focused talk and much less developer tooling-focused talk. My involvement in Clang is actually mostly with tools, with building tools on top of Clang. That's why I got involved with it. That is our primary motivation. And I want people to be aware that this is not a potential, maybe even a near potential, that we have passed the threshold at which we could trivially write advanced source analysis and manipulation tools for C++ without writing a parser. We have written, and you can go and find in the open source repositories adjacent to Clang, they're currently under code review, you can find tools which will do automatic source transformations of C++ code. Correct automatic source transformations. They actually look at the AST, they look at it with the same kind of rigor as a compiler would when generating code, and do provably correct transformations to fix design problems. We are using this very actively within Google. We do major refactorings by doing this at scale across the C++ code base. Automatic source code, like automatic refactoring and rewriting of C++ code is no longer a someday, it's a today, it's a yesterday, it's for the past 3 months. Okay, this is happening now. And I think people need to start thinking about that, because you need to actually be thinking, you need to bring back all those ideas for the past 20 years and start implementing them, because we have all of the facilities. You can write a source to source, like a source transformation on top of Clang in 100 lines of C++ code.
So he wanted it 20 years ago. I completely, so he's got he's already bled.
I'm sorry.
He's already paid. How can he get how can these people get what you just described?
So right now, there is one patch missing to be able to do this. It is under code review. I'm hoping it's going to be submitted in the next couple of weeks. At that point, you will check out the Clang source code. You'll build it. There's going to be an examples directory, and inside of that, there's going to be a tool that actually does this, and you can just, cargo cult from there. It's a tool that looks at the source code and it finds every place where you call CSTR on a stood string object, and then pass it to an interface that accepts a stood string object. Because at some point it accepted a char star because it was old and crufty. They got around to fixing the interface, and one of the nice things about fixing the interface is that all of the existing code kept working. One of the sad things was that now all of the existing code is kind of bad, right? But this is a tool that actually goes through it, walks through all of these interfaces, finds all of them, deletes the .cstir call, makes sure that it actually didn't matter. So we found bugs with this where people had 0 bytes in their string, and they were implicitly using the .cstir call to remove a suffix from, like, terrible things were going on there. But like, you can find this automatically. Like, they didn't have to do this by hand anymore. right? And we've got, if you've ever heard of a project called Include to Use, it was a prototype include management tool built entirely on top of Clang. Now that we've got the infrastructure for building tools on top of Clang really figured out, and we're building it out in the open, we're actually going to be taking that prototype and re-implementing it as essentially a product, as something that you can just give any engineer and they can use it day in and day out. And so these things are actually happening.
Open source?
All in the open source. All of this is in the open source. None of this is inside of Google. All of this is going directly into the open source. We've been doing this for about 6 months. We've been spending the time trying to get the design vetted by the rest of the community. Right? We prototyped it internally because we had to. We were at the point where we had to have the ability to change our entire code base automatically, or we could not make progress.
Let me just extract a few things. You're talking about massive, large Google scale, automatic refactoring analysis tools, less than 100 lines, manipulating ASTs for C++.
Yes.
Open source.
Yes.
This is important.
For Bjorn, I also have to say, and one of the hardest things we did was we restructured an interface call that was buggy inside of a macro argument. We can survive macro. It's painful.
I was amazed when I saw some of your examples. But I'd like to point out that I've wanted this for more than 20 years. And ever so often, you find it. Even 20 years ago, you find this company has a very nice tool inside it, can parse, it can refactor and such. And the other company has something else. There has always been 2, 3, 4 systems that would do sort of what we wanted, and you couldn't get to them. You couldn't use them in a combination. They didn't have a user base that could maintain them over decades, so they disappeared again. It's one of the cases where the fracturing of the C++ community, because it was so big, it grew so fast before there was a knowledge of how to run communities, how to share code and such. We were very early out, and it seems to be changing, and that's very good.
There is a reason I explicitly asked you to come and talk to us about Clang, because Clang is so important to understand what modern C++ is really all about on many levels. First of all, that you can do all these things. It's not your granddaddy C++. However, you can do them because for the first time in at least a decade, maybe 2, we're dealing with a new C++ compiler. Yep. And third, of course, it just shows major companies are actually investing, the world's largest technology companies investing in new C++ compilers, and this is the result. This is C++ rebooted and written from the ground up 20 years later with everything we now know and have. Can be pretty cool.
And I cannot emphasize this enough, Bjorn. We are absolutely committed to every single line of code involved in this being in the open, being maintained and sustained in the open by a diverse group of people spanning the industry. There's no other way for it to be viable. It has to be diverse. We have to have it in the open. We have to have people like you contributing to it, or it doesn't survive.
Applause time. We have 2 minutes.
We have 2 minutes, 2 questions. You're going to have to be fast in your answers.
Yes.
Let's try to.
Three.
This question is for Herb. In designing C++ AMP for heterogeneous parallel programming, why did you choose the library route instead of, as opposed to something like pragmas like OpenMP? And would any of the other panelists have chosen a different approach?
So when you said the library route instead of the language route, I thought you were going to say, not instead of the preprocessor route. It's not quite preprocessor. Let's just say that OpenMP is fine for what it did, but it's an old tool written in another era, and it's an industrial strength duct tape tool. It's industrial strength. You can do industrial strength work with it, but it's clearly outside the language. It's not integrated well, and I've said that in front of the key OpenMP developers, and they nod. That's what it is. We felt it was very important, in a nutshell, to have as few language extensions as possible, We managed to factor it out and spend many months and figure out we just needed one. And it's a feature that we do the rest as a library. We consider that a big feature, that the rest can be done as just a library once you have the one single little language extension.
But
Which is that?
Restrict. So to be able to say you're programming in a subset of the language for this function and overload on it and everything. Yeah.
But wouldn't other compiler? But wouldn't other compilers?
We have to take another
question.
Thank you.
Very last question. Yes, no.
Yeah, so I'm an experienced designer, which means for every hour I spend coding, I spend an hour in Photoshop. And being with you guys the past 2 days, thank you for a great conference. I can safely say I'm probably the dumbest person in the room, and I'm totally okay with that. My question appropriately, though, is we're talking about the language and how it's modern, C++, it's easy to use, we don't have this. Are you guys ready for what happens when the rest of us take the bait, right? Because we usually come from scripting to managed, and now we're starting to jump into native. We saw what happened with Objective-C, ARM from post-build, right? I mean, these floodgates are coming. If languages are living and they are a reflection of the culture, what happens when the C++ community collectively drops in intelligence, right? When all the rest of us start coming in, but you guys can start picking up design skills. But I mean, what are the implications? Because it's been such a closed community for 20 years, and now you're opening the doors. Are you ready for what you're going to get?
We're not ready, but it has happened several times before. We didn't get to the current size by not having that happen. So we're not ready, but the tools are being worked at, the libraries are being worked at, the textbooks, teaching materials are being worked at. We're working at the style level. Some of us is writing as fast as we can put good enough text together. So one thing that's going to fail miserably, if history has anything to say, go by, is to get the teachers and the educational community up to speed. They really love to be either stuck in the 1900s or to go for something brand new, radical, and flashy. And C++'s growth, however dramatic and significant as it is when we know it, doesn't quite fit that pattern. So I think the thing I worry about is the education. But we're working very hard on all the areas we can.
So
Thank you very much.
I want to say, I think the biggest indicator that we may, if not ready, we may be able to deal with this and deal positively is where you are. Thanks to Charles, thanks to Herb, and the lineup of amazing people we have up here, and Bjarne giving us this wonderful insight into the language. These events and these contributions to the events are what will help bring the new wave of people coming into C++ up to speed, up to the technical bar, and make them productive. And so I want to make sure we thank you guys for organizing this and being here and sharing the knowledge.
Yeah.
Excellent. Thank you.